This video is Module 2. This is switching concepts. So in this video, we're going to look at how Layer 2 switches forward data. Two of the objectives that you need to know for Module 2 include frame forwarding, which is how frames are forwarded within a switch network, and switching domains. So you want to understand the difference between a collision domain and a broadcast domain. When you're looking at switches, it's important to understand some of the concepts. One of the basic concepts is the difference between an ingress port and an egress port. An ingress port is the term used to describe the port where the frame enters or is incoming into the device, whereas an egress port is one that describes the frames as they leave or exit the device. So if you need an easy way to remember these, I would remember incoming, ingress. So they both start with an I, and exiting and egress both start with an E. So that might be just a little simple way to remember. So it's important to understand how a switch actually learns an address. Now, switches keep information within a content addressable memory table that is located within the RAM on the switch. If you'll remember, your RAM is temporary memory. So whenever you turn off the device, it would erase whatever is located in the contents of RAM or your CAM table. It also means that as the device boots up, it doesn't have anything in its table. So in order to learn what's in the table, what the switch actually does is learns based on what comes in on the incoming port or ingress port. So if we were to look at this port table here, notice we have information in the port table, but just for understanding this, so say we had something attached to each one of these ports, and as a frame moves within port 1 and it's destined towards port 6, for example. Well, your switch doesn't know what's attached to each one of the ports. So what it does is as the data frame moves in or goes into port 1, then it populates the address table for port 1. Now, MAC addresses, as you probably know, are 48-bit addresses, and they're really long, but just for learning purposes, those have been abbreviated here. So as data comes in on port 1, then we're going to add the MAC address of port EE on port 1, because now we know that. But since the device doesn't know the destination, what it does is it will forward or broadcast the frame out all the ports except for the one it received it on, because it knows what's incoming on that port. So what it would do is broadcast that data out ports 2, 3, 4, 5, and 6. If you'll remember from your OSI model, from your CCNA2 course, you'll remember that as information is received on layer 1, which is the cabling, it then moves it up to layer 2. Layer 2 is where those MAC addresses are checked. So what happens when this data that is not destined for 2, 3, 4, or 5, those devices will all check the MAC address and it doesn't match their own MAC address, so it just drops the frame. Whereas with port 6, that MAC address will match the one located on that device. So then that frame will start moving up the OSI model. It'll strip off the headers at layer 2, then 3, and then 4, and so on until it reaches the application layer at layer 7. Then when port 6, whatever the device is on port 6, wants to respond back to whatever's in port 1, it sends a frame. So it has the destination address of port 1, whatever's in port 1. So when it sends that frame back in on port 6, then the MAC address says, okay, now I know what's on port 6, because again, it's looking at the incoming MAC address, and so it populates the address table for that one. Then the next time something on port 1 wants to send something to port 6, that's already in the table, it can send it directly there. And that's the way it would normally occur on a switch, is that it consults the table and then it sends it out directly to that device. But if it doesn't know, it does forward out or broadcast that out to all the devices except for the one it received it on. And again, that's all the ports that have devices attached to them. And so that's how the operation of a switch actually works. Now there's different methods in which they use to forward your data. So this two-step process that I was referring to earlier, the learn and the forward are listed here. So it would look at the source MAC address, populate the table, and then look at the destination address to determine what port to send that frame to. So I would encourage you to view this video in depth. Now there's two methods that your devices will use to switch the frames. There's a store and forward method, and then there's a cut through method. The difference in this is one's faster than the other, and also what they use to view within the frame before deciding to send it. The store and forward method has more latency or delay, whatever you want to call it, because it makes a decision whether to forward a frame after it's received the entire thing. So it does a CRC check at the end and make sure there's no errors. That works great for email, but if you want something a little bit faster, you'll want to use the cut-through switching method. And that one just examines the destination address and then sends it. So if you're looking at a frame, store and forward would look at the entire thing, whereas cut-through would just, again, look up to the destination address and send that. I would encourage you to do the switch it activity here, and that's located on 2.1.8, because this will test your knowledge on how a switch forwards data. So what devices it will go to, how it forwards it out. You can check yourself, you can do new problems. If you're really not sure, you can have it do the show me. But I would encourage you to do this not only for your module exams, but on the CCNA exam as well, because I'm pretty sure I have seen this more than once on the CCNA exam. So once you understand your forwarding methods, the other important concepts here are your collision and broadcast domains. Earlier switches operated in what we call a half duplex mode. So with a half duplex mode, devices can send or receive, but not at the same time. But fortunately, our newer devices operate in full duplex mode, which means that you can send and receive at the same time. So it's important to understand those concepts of full duplex and half duplex. Now again, newer devices use full duplex, so if you have two switches on a network, they will try to operate in full duplex mode if they're both able to do so. Now, if you have a newer switch and an older switch, and the older switch is only capable of half duplex mode, then the newer switch will also operate in half duplex mode. Kind of the concept of you're only as fast as your slowest link. So that would be the concept here, because when switches communicate with each other, they have to have the same settings on both ends of the link. So what is a collision domain? A collision domain is any area or any time you have more than two or more devices that try to communicate at the same time, then you can get a collision. Okay. So that would be your collision domain. So anytime you can have two devices where they could happen to transmit at the same time, a collision can occur on the network. Again, with older devices, that may have happened more because you'd have several devices, say on an Ethernet network, where they're all trying to transmit. Full duplex, it's not really an issue, but it's still important to understand the concepts. Now, broadcast domain is where your broadcasts are bounded within a network. So in this scenario right here, we're going to look at, okay, this is kind of a subset of this one below. We'll see that as data is incoming into the switch, it will forward it out all the ports that it's attached to, including the other switch. So it will be passed all the way across. So you will see this happen here. So it'll go all the way. So all the devices on switch 2 will also receive that. So they're all in the same broadcast domain because they're receiving the broadcast. So how can you bound or stop a broadcast? Well, that's where either VLANs or routers would come into play. So really, they don't mention VLANs a whole lot. In Module 2, they really talk about routers being the boundary of a broadcast domain because a router does not forward broadcast. Switches forward broadcast, routers do not. Remember that switches reside at layer 2 on your OSI model. Switches reside within a network. They're internal. They're always internal. They will never be external. That's where the difference between routers and switches is. As a router is used to connect networks that are not the same. So the router kind of becomes the boundary to your network. So that's why one reason why broadcast will stop at your router interface. So why do you want to try to talk about or understand all these concepts? Why are switches important? What's their role within a network? Well, originally we did not have switches. So you had hubs and you had, well, basic older switches. They did not help a whole lot with the congestion on the network because they operated that half duplex. So you had a lot of collisions on the network. It was not very fast. Once we started introducing switches into networks, you started seeing faster port speeds. If you can have faster internal switching on the switches, then things moved a little bit faster. Larger buffers, more ports on your switches. That's what the higher port density is referring to. Introducing switches into the network made switches a lot faster and more efficient. Because each port on a switch is its own collision domain. So that's different than the older hubs and the older devices, because everything that came in just went out all the ports. Whereas a switch, you can kind of separate some of your network traffic. You can cut down on the amount of data that's moving throughout that network. So it did help a whole lot with some of the network congestion. So I believe that is the end of Module 2. You want to make sure you know your frame forwarding and the switching domain. Make sure you can do this module quiz. So if you can do that, then you should have a good understanding of Module 2.